Okay, so today we are going to be working with dialysis tubing. This is going to be excellent for describing diffusion in our labs. So here I have an example of some dialysis tubing. So what we're going to do is we are going to take it out of our package, and we're going to be cutting off a piece of tubing. So we are going to cut off maybe about 4 inches or so. And what I'm going to do is I'm going to first pre-soak it before we do anything else with it. This way we can sort of get it to start opening up. So what we are going to do after I've gotten it a little bit wet is I'm going to take a little bit of our twine, and probably about a few inches, and we are going to tie it at the end of our tubing. Simple overhead knot should be just fine for this. So get that taut and do another knot like so. And we'll trim off the excess. Now, we could continue like this, but I'm going to cut off an extra piece because I want to make sure that we're not going to have any kind of leakage. So another piece. And this usually is going to help it when you have a couple set of hands, but if you don't, it's perfectly fine. So what I'm going to do is I'm going to twist this, and we're basically just going to do the same thing. Just a little bit of extra protection. Alright. And I'm going to double that knot and trim off our excess. So now we've got a small piece of dialysis tubing. Next, we're going to open it up. So I'm going to need to soak it a little bit longer because it's not quite opening. So what I've done is I've actually soaked the dialysis paper a little bit longer in our water. So we want to leave it in for about a minute or so. A little bit longer is not going to kill it. And now we're going to want to open the tubing. So when it's dry, it's going to appear as a flat piece of plastic. But if we move it between our thumb and forefinger, we actually can get a slight opening. Next, we're going to want to fill our dialysis tubing with our solution. Now, when we do our labs, we're going to be doing starch and glucose solutions, about an 80% solution, but we're just going to use simple water for this demonstration. So I've got a little dropper here, and I'm going to insert it into my tubing, and we're going to start to fill it. So this is where another set of hands can definitely come in handy. Alas, as I mentioned in class, you can't just grow matter out of nothingness, and we do not come with 4 hands. So I'm going to just finish up here, and now I've got our tubing filled, and I'm just going to sort of rotate this so we can have it sealed up. Do some more rotating. And at this point, we'd have another set of hands, hopefully, that could finish tying a little bit more twine to it. But if you're as dexterous as I can sometimes be, this might not be one of those times. And we'll double knot that. Now we have some tubing. Our dialysis tube now has our solution, and you can always add more to it. It does have a lot of stretchability, and we would add another piece of twine there before we would eventually submerge it into water. And what this tubing is going to represent is the membrane, where it's semi-porous and it's going to allow certain molecules in, but keep other ones out, and vice versa. And this can demonstrate what can move in and out of our membrane.